Greetings, the Asteroid 30 here, yet again with another video. This is a video review, I suppose, of a already assembled product. Original Soundtech product. Ooh. And it's a DX0809 high quality and best product. Hi-Fi Stereo Amplifier 60 watt. Now, stereo, yeah, okay, typo. The specification, it's not multiple, it's only one specification. Input sensitivity at 1 kilohertz, which is absolutely meaningless, so we'll ignore that. Maximum power output at stereo 60 watts. Now that to me means 30 plus 30. It wouldn't be 60 plus 60, otherwise it'd be stereo 120 watts. So I reckon that this little amplifier could deliver at least 30 watts, but that's only at a DC supply voltage of 12 to 15 volt with a minimum current capability of 3 amps. Now, yeah, even if the IC that it uses is an integrated circuit power amplifier, even if the IC managed to output 12 volt peak to peak, draw 3 amps, that's only 36 watts, so it is possible, but I doubt we're going to get anywhere near a 3 amp current draw, even with both channels driven. Well, we'll see. And this is the bit I like. Original tested 1x1 system. Well, I'll get to that in a minute. First, let's open the box, which is a bit squashed. That's how it came in the mail. This is available on the Banggood website, so I'll put a link in the description as to where I've got it. There's the module there, wrapped in plastic. Take it out of the plastic. Now, these connectors are absolute shit. They're the most shittiest quality. That one's not even all that straight, to be honest. This input connector leaves a lot to be desired. We've got over here a 2,200 microfarad 25 volt cap. Then another 680 microfarad 25 volt cap. What's interesting here near the DC socket is we've got this large power diode. So that would be considered a wrong way voltage protection diode. So if you connect it to the supply backwards, you're not going to blow anything up. Also would form a half wave bridge rectifier. So technically speaking, you could put AC on this input, but I wouldn't exceed any more than 12 volt AC, because remember, you've only got 25 volt DC caps here, which are basically on the supply because they're a linear supply. So you will blow the capacitors up quite easily if you exceed 12 volt. 12 volt at DC is roughly 17 something volts. So we'll say 12.6 AC roughly there, multiplied by 1.414. Yeah, 17.8 volts, so you wouldn't want to exceed 12 volts with that. Now, the overall quality of this board is crap. Now, they say it's tested individually 1x1 system. Yeah, well, that's interesting considering on the circuit board under here near the heatsink, I found a component leg actually cut but bent over in contact with the heatsink. That's nasty, because that can cause a short circuit. But the board was not completely cleaned up properly of any bits of crap like this before applying the heatsink or mounting the heatsink to the circuit board. So yeah, that just fell off when I hit it with my finger now. So saying that this is a high quality and best product and tested 1x1 when you've got shit like that, I mean Christ's sake, look at this. They haven't even cleaned off the burring of the heatsink when they drilled the hole. That's really top quality there, guys. But then again, don't forget, this is a Chinesium kit. well, it's not even really a kit, it's a complete module. What I'm going to do is I'm going to take this heatsink off and see if they've at least applied some heatsink compound, which it looks like they have from what I can see down in the gap there, but yeah. By the way, this uses a TDA8946 IC. We'll look that IC up in a minute. What's interesting here is, though, if we look up here, there's a 47 microfarad 25 volt capacitor missing. Now, everything else is installed in the board, bar that. And I'm still trying to figure out as to why. There's no real reason to leave it off. What that actually connects to, I don't know. There's no schematic for this, obviously, because it's pre-assembled. Why would there be a schematic? But yeah, that's interesting. I don't know if all these modules come without that capacitor. So I'll turn the module upside. No. So we'll take a screwdriver and screw the heatsink. Now there's a little bit of heat transfer compound. I wouldn't call that a great deal. And the soldering on that IC is shocking. That is pretty piss poor soldering. Yeah. That and the fact that there's heat transfer compound everywhere, all over the board, and yeah, it's just nasty. I mean, I don't even know what the hell that is. It looks like where they've missed with the soldering iron and got the solder mask. Yeah, it's not the best, and there's a considerable warp in that PCB. There's one thing about these Chinese bloody amplifiers and stuff. They always insist on using linear potentiometers wired in a standard volume control configuration, because here is the ground plane going all the way around the board. That is the counterclockwise position of the pot. Same as the mic control over here. It's wired in the standard volume control configuration. You've got input coming in this side, because I can see by following the trace that it does go back to the left hand input socket down here at the bottom. So it is connected in a standard volume control configuration, but they've used a linear pot, which I have said many a times, a linear pot volume control does not make. So they've used linear 100k potentiometers dual gang all throughout the board. This is the treble pot and this is the bass pot. That's another thing about the Chinese, is I don't know why they always inverse the treble with the bass. From convention, I guess you could call it, or the way I look at things is bass always comes first, treble comes second when going from left to right. So that's annoying, but these two pots are not going to work as volume controls. But yeah, if I want to, I can sit there and unsolder that, because, well, this is only a single-sided board. It's not double-sided, so getting these pots off would not be a problem. I do actually have some replacement pots, unfortunately not with a shank that long on it. But anyway, the preamp section is using a JRC 4558, which would be a dual op amp. That's the preamp there. Not sure whether it's wired in inverting or non-inverting, most likely inverting. And the back sandal circuit over here also uses another JRC 4558. This is an active back sandal. And yeah, they've used a lot of ceramic caps, and yeah, these fun little guys down here. Yeah, but the actual quality of the board is pretty crap. I mean, even by single-sided standards, I mean, there's even a chip in this corner of the board when they've cut it. It's just crap. But I mean, what do you expect for $14 odd is what I paid for it. Now the next question is of how to get power to it. And this solder joint looks like absolute shit. Yeah, that joint there, it's not even soldered properly. Anyway, there's the one end of the diode, that's the anode of the diode there, there's the cathode, so that would be the positive input, so that would be the tip, and this is part of the ground plane. Yeah, because if you follow it, it goes all the way up here, around here to a makeshift star earth point, and then that comes all the way down along the edge of the board to form the 0-volt rail. Well, then it stops here and then disappears. It doesn't go over to here. So where does that go after that? It goes around there to there, off down there to there, up there. Well, that's interesting. That's just very fitting up there. Okay, audio amp. Yeah, it's okay. So what I'm going to do is I'm going to look up the TDA8946 and we'll have a look at its specs. But how am I going to get the power? Well, as I was saying, there's a diode here. I can connect the positive lead to the anode of the diode and the negative to some point here, and that'll give me a supply voltage, because yeah, the likelihood of me finding an adapter to fit that is going to be next to impossible, so I'll just jerry rig it to get power to it. But let's look up the TDA8946, shall we? So I printed out the first 4 pages of the data sheet, and immediately it says it's a 2 times 15 watt stereo bridge tied low BTL audio amplifier. So if we look in the general description, it says it's a dual channel audio power amplifier with an output power of 2 times 15 watt at an 8 ohm load and an 18 volt power supply. So they've deliberately limited it down to 15 volt, where the maximum that the chip can take is 18 volt. So the best we expect to get out of this is 15 watt per channel. So immediately it's nowhere near a 60 watt stereo amplifier. It's nowhere near 30 watt per channel. You'd be lucky at the voltage, minimum voltage of 15 volt, or maximum voltage of 15 volt, I should say, getting anywhere close to even 15 watt. So we'll see. Features a few external components, fixed gain, so it only has a unadjustable gain. Standby and mute mode, no on-off switch, plops. Low standby current, high supply voltage, ripple rejection. Outputs short circuit protected to ground, supply and across the load. Thermally protected, printed circuit board compatible. Well, I should hope so. Applications, mains fed applications, example TV sound, PC audio, portable audio. Okay, voltage supply, minimum of 6 volt, typical 18, and the maximum of 25, so okay. Quiescent supply current, when the VCC is at 18 volt and the load at the output is infinite, in other words unloaded. 20 mA is the typical and 42 maximum. So that's the block diagram of the internal workings. We've got 2 amplifiers sections here. One's non-inverting, which is this one, and this one's inverting, and we just have a buffer controller amp in front of those two to give it the 180 degrees out of phase signal to this one. You connect your load across there and there respectively. You've got short circuit and temperature protection crap in there. Standby mute logic. So this would be fed, it says mode on this pin, so you'd feed it with some form of TTL logic, I assume. Servo input there. We have both inverting and non-inverting inputs here, so it is like a standard op amp to a point, but you cannot change the gain of the amplifier. To finish the specifications here, output power with a total harmonic distortion of 10%, keep that in mind, with the resistive load being 8 ohms and the VCC being 18 volt, 13 watt minimum, typical 15 watts. Now that means it's outputting 15 watts with a total harmonic distortion of 10%, which is crap. So the amplifier will be clipping to shit to get anywhere near 15 watt. So with the total harmonic distortion at the power output equaling 1 watt, we have got 0.03% typical and 0.1% nominal or maximum. So at 1 watt, yeah, the total harmonic distortion is, yeah, it's okay. Voltage gain, minimum 31 decibel, typical 32 decibel, and maximum of 33 decibel. So that's all there is to really speak about this TDA8946. It looks like it's running on a single-ended supply, or it's a single-ended supply design IC. However, these op amps are obviously running on bipolar. Now you can make a op amp work on a single-ended supply quite happily we take the positive non-inverting input of the op amp, that's your output, and we put it through a resistive voltage divider, and yeah, that side goes to ground, and then this, which is normally going to the negative VCC, becomes ground. So say that was pin 8, that's pin 4. Normally that would be the plus 15 volt rail, pin 4 would be the minus 15 volt rail for example's sake. And if we use, say, two 100k resistors in this resistive divider here, we're now making this, and that would be your nominal resistive gain feedback network there out, and you'd have your in over here, for instance. Then this op amp will now work quite happily on a single-ended supply. So that's how they would be doing that in here, by using a resistive divider, and without too much looking, to reverse engineer this back to a schematic, which I desperately wanting to do, but at the same time I don't, because it's time consuming and pointless. Yes, I would assume, yes, using a resistive divider in this sort of configuration on both these op amps in order to get it to work in a single-ended supply situation. But remember, if you do it this way, if you had only like 15 volt coming in here, that means this op amp's now only operating on half, because the op amp now sees 7.5 volt at pin 8 and 7.5 volt negative at pin 4. So just remember that it's now actually operating at half its voltage. But yeah, there's a big solder ball here too. Well, I have no idea where that came from and why it was on the top of the board, but yeah, there you go. That's high quality and best product right there. Now, I haven't done much for the last 15 minutes except talk about shit, but what I'm concerned about is why there is no 47 microfarad 25 volt capacitor in here, which looks like it's going between the negative and some pin on this IC. So where that's going is beyond me. So we know that that's going to ground. This side is going to okay, that's going to pin 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. Pin 16 between that and ground. And it also has a resistor coming off it going somewhere else. Right, well, according to the data sheet, both pin 3 and pin 16 of this IC are VCCs, so that's probably not a very important capacitor. So we'll leave that alone. So what I'm going to do is I'm going to apply some more heatsink compound heatsink transfer compound, heatsink compound, whatever you want to call this white cum stuff, to the IC. A little bit more than what was on there, because that is not a great deal of compound. That was probably a little bit too much. That's mostly watery now. Because I've taken it off already, I want to make sure that I put some more back on. I'm not going to clean the old stuff off. I mean, seriously, what's the point? So I'll put this back together. And we'll do some tests on it. So that's now tight. Get rid of this data sheet and that piece of solder dag. So what we want to do now is get power to it, at least. There's a little LED down here, so that should light up when there's power present. So I need to find a good point to connect my ground lead to. That heatsink's not even drilled straight. I've just noticed that it's crooked. Anyhow, looking for a good ground point. That socket is really doing my head in, being bent like that. That's better. I don't really want to have to solder anything to the board to make it work. But yeah, I'm probably going to go through and rework most of the solder joints anyway. There isn't any convenient location to connect the ground, so I might have to bust out the soldering iron to put a wire on there to actually connect a jumper lead to. Okay, well I'll do that then. Now, but before I do that, I just want to clarify one thing. I may be wrong here when I said that this IC here, the second op amp, is for the back sandal circuit for the tone control network. I reckon more likely this would be the pre-amplifier for the microphone inputs. That'd make more sense. So this would be a passive back sandal circuit, and these two op amps are either connected together at its output in inverting as a form of summing amplifier, maybe with fairly high gain to compensate for the losses in this network. I don't know. Without a schematic to this, it's awfully difficult to surmise how it works, but yeah, for all intents and purposes it doesn't really matter. But I reckon that one's actually for the microphone sockets. But now that I've put the heatsink back on, I can't actually trace the routes to see if it goes up to this IC. It probably does. Anyhow, let's hook this up to a supply and get started. Oh, the sun came out. Okay, I've got the power supply set to about 15.5 volt, thereabouts. Should be fine, as long as we don't exceed 18 volt on the input. Should be okay. I've got it hooked up across the other side of the power supply that's hooked across the amp meter here, so I can see what the current draw is. I've got the left channel hooked up to the multimeter on the voltage scale to see what sort of DC offset we've got. So I'll turn the load on, and we have about 76 millivolt there, and a current draw currently of 130, 120 and falling. About 100 mA current draw. That's okay, and that LED down there, I don't know if we can see it, is on and fairly bright. We have 74 millivolt on that channel. So that channel is fine, not a very large DC offset. I will switch, it's actually negative, I'll switch the channels around with this live because I'm cool like that. And we've actually got a higher DC offset on this channel of 86 millivolt. It's actually positive. So it's 87 odd millivolt there on the right hand channel. And if I switch it back, and I haven't reversed the leads round or anything, we've got minus 74 there. Interesting, isn't that? But the power supply is now settled down to 50 mA current draw, so that's fine. You may notice I've got some knobs on the potentiometers here. That just gives me a visual reference of where the center is, etc., and where this knob is pointing. So I'll turn that off. Okay, as jerry-rigged as that is, I've got 1 kilohertz, 1 volt peak to peak on the DDS. DSO is hooked up across an 8 ohm dummy load on the left hand channel. Got an RCA plug plugged into the left input, going across another RCA plug over here to give me the connections to the RCA cable to the DDS. Fun. Turn the load on, and yeah, we can't see anything unusual on the scope, so I'll just increase the music volume, as they call it, and I can actually see an output signal. Right, so now I'm going to exceed the voltage per division of that setting, so I'll set it back to 5 volt per division and drive it into clipping, which I can just do. And I'm looking at the current draw on the power supply. It's only 830 mA so far. I can't quite make it clip. So what I might do is I'll change the amplitude to 2 volt peak to peak in, and it's immediately clipping. So as we can see there, it's clipping. So if I back off the volume, it's not clipping anymore. So I'm going to call it there. We're looking at 20 volt, yeah, 20 volt we'll say peak to peak. So I'll turn that down, so because I don't trust that heatsink in any way, shape or form. Okay, so we've got 10 volt peak. We'll square that, which is 100, and we divide that by our load. We get 12.5 watt. So we're lucky to get 12.5 watt. So in stereo we're going to be getting roughly 24 watt, but maybe 20 watt with both channels driven. So what I'm going to do now is I'm going to swap the inputs and outputs around and test the second channel, make sure that that's working. And I've just swapped them around. I can see, yeah, there is a voltage there. Increase it and we'll see if it's the same before clipping. Probably about 200 millivolts more, so it's not exactly balanced. Actually, believe it or not, that heatsink's not getting very hot at all. Okay, so what is our frequency response going to be like? So looks reasonably flat. Maybe it starts rolling off at the 12 kilohertz range. And rolls off towards the 20 hertz, 30 hertz range. It's not perfectly flat, but it's flat enough. So if we go back to continuous wave now, I'm going to set this to a frequency of 60 hertz will do. Now I just want to see what the bass response is like on this. This is with the control centered, and it's starting to clip, so I might have to reduce my input voltage. So I'll just drop the control down to about half. I'll change the voltage per division to something we can see. Play with the bass pot. You're getting 20 volt peak to peak out, so that would be clipping. No, it doesn't even clip, so that's alright. It's starting to, but it's not too bad. At cut we're getting 1 volt. At boost we're getting 20, so that's with respect to the volume control being at halfway. Okay, the frequency response of the amplifier is reasonable. I wouldn't say it's all that wonderful, but it's reasonable. So now we can probably put it in through some speakers and actually hear what it sounds like with audio coming out of it. Okay, I've got everything set up. It's hooked up to some speakers. I've got the volume right down. I've got the CD player hooked up to it. Yeah, that one's not plugged in properly. Now it is. I'm going to test the music input source first, and then I'll test the microphone inputs. I don't have a microphone, but I'm just going to use my bass guitar, do the same thing to a point. I mean, there's a difference in the output levels of the pickups compared to a microphone, but yeah, we'll soon see how it sounds. It might be a bit distorted, but volume's right down, so I'm just going to select a track. Yeah, that'll do, and there is a pop at the output, so I'll press play and we'll see what sound we get out of it. Sounds reasonable. Treble. Yeah, treble doesn't do much past center till the extreme end. It's bass. Bass works nicely. Let's try a different track. Just stop that for a minute. That sounds alright. Couldn't hear any unusual sounds in the output. Not impressed with the on-off pops. Well, at least the on pop. Okay, I'm going to plug my 4-string bass into one of these inputs, which that socket's a bit of a bugger. Turn the volume up. That volume control doesn't affect it. Okay, so you can actually mix the microphone with the incoming signal. Albeit this is not the best sort of test, but yeah, I'm really exceeding the excursion of the drivers. Turn the bass down. Actually, the bass doesn't seem to do much to that. Oh, it does. But I'm not sure what sort of filter network they're using on the microphone inputs there, but it sounds really muffled. So it has a very low pass content to it. There's not much high pass there. Yeah, it actually sounds quite crap. So I'll swap inputs and check the secondary input. It does sound like it's coming out of both channels. So yeah, it's coming out of both speakers. But yeah, the bass guitar is probably not a very good test. But yeah, the module works. It's okay for what it is. It's not the best thing in the world. What would I use it for? Well, I'd probably use it for a test amplifier, a bench test amplifier, like I've already built one, but I'm thinking more along the lines of, well, it's all in one unit. All I need to do is, to get this to fit into a case properly, is find some nuts that fit these. The potentiometers are missing their nuts as well, which is kind of annoying. But I would remove all the sockets off the board and run wires to the board from the sockets on the back panel. So I could use a slightly bigger case, because finding a case for this to fit into exactly would be a little bit difficult. But however, it works for what it is. Is it great? No. It's okay, but it's not great. So what happens when we turn it off? We get a pop. So it's okay for what it is. It's not the best. Would I recommend buying it? Yeah, maybe, maybe not. But is it worth $14? Pretty close to it. I mean, you get what you pay for. This is probably the crappiest thing that I have ever bought and tested. But it does output a clean audio signal from a source such as a CD player or whatever. So yeah, it works and it sounds pretty good in the frequency response. The frequency response to the microphone input is yeah, it's more low pass. Not sure what they're doing there. But anyway, I'm going to leave this here. It's, as it says on the circuit board, an okay audio amp. It's not the best audio amp, but it's definitely not the best quality according to the box, wherever that's gone. I seem to have lost that. Yeah, it's not exactly the high quality and best product they claim. Nowhere near. But it does work for what it is and for what you pay for it. So now I'm going to leave this to your own discretion. If you want to purchase one, I'm going to stick a link in the description, and you can, you know, buy one if you want. Anyway, I'm the Astro 30, and if you enjoyed this video, please remember to give it a big thumbs up, and you can always comment down below. And you can always follow me on Facebook and Twitter. The links are in the description as usual. Anyhow, this is the Astro 30 saying see ya in the next video.